Kafka is the broker everyone asks about. It's on the job description, it's in the system design round, it's the thing your senior engineer keeps mentioning. And most explanations of it start with the wrong thing. They start with brokers and clusters and zookeeper. We're not going to do that. We're going to start with the one idea that makes Kafka click. And once it clicks, everything else falls into place. Ready? Here's the idea. Kafka is not a queue. Kafka is a log, an append-only distributed log. Let me show you the difference with a tiny mental picture. In a queue, you've got 3 messages. A consumer reads the first one, and it's deleted. Now there are 2 left. The queue's whole job is to hand out work and throw it away once it's done. Kafka does the opposite. Messages get appended to the end of a log, and they stay there. Reading a message does not delete it. Instead, each consumer keeps a little bookmark, its offset, that says, "I've read up to here." So one consumer, say a billing service, might have its bookmark at position 3, and another consumer, an analytics service, has its bookmark at position 5. Same log, same messages, 2 independent readers, each at their own spot. That one difference, messages are kept and consumers track their own position, is the whole ballgame, because it unlocks 4 superpowers at once. Multiple independent consumers all reading the same data. Replay, where you can move your bookmark back and reread history. Event sourcing, where the log becomes your source of truth. And stream processing, computing over the data as it flows. Okay, now let's add just enough structure to be dangerous. A few key components. A topic is a named stream of messages like orders or clicks. Each topic is split into partitions. A partition is a single, ordered, append-only log living on disk, and it's the unit of parallelism, the thing that lets Kafka scale. A consumer group is a set of consumers working together on a topic, where each partition is handled by exactly one member of the group. And the offset is that bookmark, the position in a partition. And remember, the consumer owns it, not the broker. Now, let me really hammer the mental shift from queue to Kafka, because this is where interview points are won. In a queue, who tracks your position? The broker does, and it deletes messages after they're acknowledged. In Kafka, the consumer tracks its own position by committing offsets. In a queue, can 2 different teams read the same data independently? No. In Kafka? Absolutely. That's what independent consumer groups are for. In a queue, can you replay yesterday's events? No, they're gone. In Kafka? Yes, until retention expires. And if a consumer goes down for an hour? In a queue, messages pile up and you hope for the best. In Kafka, the consumer just falls behind. Its bookmark stays put, and when it comes back, it picks up right where it left off and catches up. So, when should you actually reach for Kafka? When throughput is high, think tens of thousands of messages per second and up. When multiple independent teams need the same data. When you need replay for audits, for retraining a machine learning model, for recovering from a bug that corrupted data. When you're doing event sourcing or change data capture, or when you're doing real-time stream processing, like scoring or anomaly detection. And one honest caveat. If you just need a simple task queue, Kafka is overkill. Don't reach for a distributed log when a humble queue will do. Last practical note. In the real world, you almost never run Kafka yourself. Self-managing a Kafka cluster is a serious undertaking. It's worth it only at the scale of a LinkedIn or a Netflix. For everyone else, use a managed service. Confluent Cloud for the most complete ecosystem, Amazon MSK for native AWS integration, Azure Event Hubs for a Kafka-compatible endpoint, or Redpanda for a Kafka-compatible engine with no JVM and lower latency. So that's the foundation. Kafka is a distributed log, consumers track their own offsets, and that unlocks replay and many independent readers. Next episode, we crack it open and look at how it actually achieves all this. Partitions, replication, and the mechanism that keeps your data safe when a machine dies. See you there.